Let's talk about paraboloids of revolution. So, a paraboloid of revolution is when you take a two-dimensional parabola and you create a three-dimensional image by rotating it about its axis of symmetry. Now, you may not be aware of this, but these parabolic shapes are seen in a lot of different places. If you look out in your backyard or your neighbor's backyard, you might see that they have a satellite dish, right? Now, it was like my backyard. My parents saw a satellite dish from the 80s, so it's this huge thing with the wire mesh. But it was a parabola, right? But nowadays they are a little bit more. It's like they're rectangular, but it's still a parabolic shape. If you look at the sideways cut of it, so if you look at it sideways, it looks like this. And then it's got this arm that kind of sits in like this. Right, so it's attached to something, and what's happening is that this main piece, that little receiver, is set to be at the focus of the paraboloid of revolution. And what that means is that all the waves that come in, they're going to bounce and they're going to hit that guy. Now, if they're coming in at a weird angle, it's not going to work. But if you're aiming it at a source, and these waves are all coming in parallel to one another, when they hit the back of the parabolic dish, they're going to hit that receiver. So that's the great thing about parabolas and three-dimensional parabolas. You may have maybe you've watched football games, and you might be amazed to hear all of the crunching sounds of the shoulder pads and the helmets on each other, right? Well, that's because you've got some dude who's standing on the sidelines, and he's got this parabolic mic. So what he's able to do is that he focuses it on one particular spot. And all of those waves that are coming in, they hit the back of this, and they bounce to that microphone. They come in parallel, and they hit that microphone. Now, what about the audience that's yelling and screaming? Well, those sounds are coming in like this. So even if they happen to make it into the microphone, they're going to bounce off and they're going to completely miss the mic. But when you're aiming it, say, like at the quarterback, and you hear him make it audible, you hear him call out the play, that's how you're able to hear that, even though you're surrounded by 50 or 60,000 screaming fans. Hooray, math. I really like this stuff. So let's do some examples with this and figure out how to answer this. So here's one that says there's a parabolic mic. So let's draw that parabolic mic again without all the other stuff on it. And it measures. Okay, well, I really didn't draw this well. Let me do this. So it says this parabolic mic is 25 centimeters across, and it's 10 centimeters deep. So the distance from here to here is 10 centimeters. Where should we place the microphone so it's going to be the most effective? The answer to that is going to be all about the focus. The focus for this parabola is where you want to put the microphone. So how do we go about finding that? Well, one of the things that we might want to do is maybe reorient this picture and put it on the XY plane so that we can more easily manipulate what's going on here. So let me take this guy and let me rotate him 90 degrees. And when I do that, I'm going to put this on the XY plane. He's going to be going up to 10 units this way, going out to 12.5 units on the right and on the left. Why 12.5? Because we're going to take this parabola that is 25 centimeters across, and we're just going to cut it in half because you would have this line of symmetry, and that's going to be our y-axis. So we're going to have these points here and here, and we're going to really cheap out and say, you know what, let's just put our vertex, let's put the vertex at the origin. Because if we do that, It really simplifies a lot of the stuff. So this is a parabola that's opening up, which means it's going to take on the form of x squared is equal to 4ay. You might say, what about the h and k? Well, I'm choosing to set this up so that the vertex is at the origin, which simplifies that form. We talked about that a few videos ago. So we want to identify where the focus is. Now we know the focus is going to be somewhere along this x-axis, along the y-axis, but we need to figure out what is the a value. All right, so let's work that out. So I don't want to use 0, 0. I need to use another point. So let's use this guy right here. So this is, it's 12.5, but let's actually make this 25 over 2. I think it's going to simplify our work a little bit later. And the y value is 10. So if we plug those into this form, we've got our x, we've got our y, and we can figure out what our a is. And as soon as we know our a, that's going to tell us that distance between the vertex and the focus. That's going to tell us exactly where we should put our microphone so that we can be the most effective with this. All right, so for x, that's going to be 25 halves squared is equal to 4 times a times y, which is 10. All right, so if I square this, 25 squared is 625. 2 squared is 4. And over here, again, I want to find out what a is. 4 times 10 is 40, so 40a. All right, well, I need to get a by itself. So I'm going to do this. And I know you may be saying, why don't you just divide by 40? Well, it's because I have a fraction on the other side. And I would rather multiply times the reciprocal so that things are just a little bit easier for me later on. Now let's try to simplify this. So 40 and 625 can reduce by a factor of 5. So 5 goes in here 8 times, and 5 goes into 625 125 times. So when I finish this, I have 125 over 32. That is my a value. It might be kind of difficult to get a sense for exactly where is this. So if we turn this into a mixed number, all right, I got to make sure that I'm doing the math correctly here. So that would be, it almost goes in 4 times, but not quite. So it goes in 3 times with 29 left over. Yeah. So where should the microphone be placed to be most effective? So the mic should be placed 3 and 29/32 centimeters from the vertex. Inside the parabola naturally. So it should be, if we're looking at this as the coordinate system, then the focus where your microphone should be would be 0, 3 and 29/32. Okay, so let's just review. When you've got these real world pictures, set it up on the XY plane and put the vertex at the origin. It simplifies a lot of stuff here. So if that's at 0, 0, you get this nice simple equation to work with right here. You plug in x, you plug in y, you can find a. Now in this case I wanted a, not 4a, because I know that my focus is a distance of a away from the vertex. So I did have to solve for a in order to get that. All right. Now this next question really does go into how I grew up. So an old satellite dish measures 3 meters across. And you know what? I think we should probably just go ahead and cut to the chase and draw it on the XY plane. So it's going to be 3 meters across, and the focus is 1 meter from the center. So I'm going to draw a parabola. try to draw a parabola. Again, just try to make sure we understand the shape, right? And this parabola is 3 meters across, which means we're going out to 1.5 meters over here and negative 1.5 meters over here. So you might think, 3 meters is kind of big. Okay, I might be exaggerating a little bit, but that satellite dish that's still in my parents' backyard is huge. It's just huge. And it's one of those where you had to actually, wouldn't actually go outside to rotate it, but there was like a little box that you would move this lever and it would actually change the rotation. Like it would move the satellite dish so that you could receive a signal from a different satellite. I still remember doing that. And of course, back then, I was a kid and I was the remote control. They always send us to do the work. But I will say that when it snowed and it blocked the signal, my dad was the one who got out there with a broom and cleaned it off. All right, so we're going to put the vertex right here at 0, 0. And it says our focus is 1 meter from the center. Okay? So we want to know if this is my focus. Let's call this 0, 1. We want to know how deep is the dish. So I don't know if my focus is going to be inside or it's going to be outside, right? What I'm wanting to know is what is that distance? If it opens up 3 meters wide and I have this particular focus, can we backtrack and figure out what these endpoints are going to be over here? And I'm going to say, yeah, we can figure that out. And you might say, well, how? Okay. From the vertex to the focus is a distance of 1 meter, which means my A is 1. Okay, very, very important here. The basic equation that we're going to work with is an x squared equation, opening up. So it's going to be x squared is equal to 4ay. All right, well, I think we know everything that we need to know, right? We know that this ordered pair right here is going to be 1.5 comma something, right? I just told you what a was. You have a very specific value for x, so you can plug it into this and find out what y is. So if I use the a, that means that the equation is going to be x squared is equal to 4y. That's the equation for this parabola. No matter where you are, that's going to be the equation for it. And if I tell you that x is 1.5, that will tell you what y is once you solve that. Now, again, I don't want to look at a mixed number because it's going to be messy when I try to square it. Instead, let's look at it as the improper fraction 3/2. So 3/2 squared is 9/4. That equals 4y. And let's get rid of this coefficient by multiplying times its reciprocal. So multiply times 1 over 4. So 9/16 is equal to y. So that tells me that the depth of this satellite dish is 9/16 of a meter. So the satellite dish is 9/16 of a meter deep. Well, that puts the receiver actually outside of it. So my picture is a bit off, right? So we said that our receiver was going to be 1 meter above the center, but since the satellite dish is only 9/16 of a meter deep, it's going to be about half as deep as that, so you would see that receiver part kind of sticking out. And yeah, you know what? I need to see if I can get a picture of that and share that. That'd be really cool. Of course, I have to drive 12 hours to get to my parents' house. And my dad could send me a picture. Yeah, that'd be great. All right, so yeah, there you go. Real-world parabolas. Putting the focus in the right spot is super critical, right? You may not realize this, but anybody out there that uses satellite TV, that's what you're doing. Satellite, sending signals. It's all about putting the focus in the right spot so that you can get as much information as possible, so that when those waves are coming in, and they're all parallel, they're all hitting the same spot, even if they're not hitting the the same part of the satellite dish, no matter where they hit, it's designed so it's going to bounce back and hit that focus. See, math is cool.